This is a tutorial on slope-intercept form. Say we were given a slope and a y-intercept. Could we use this information to graph the line of our equation? Well, remember, slope is equal to rise over run. And our y-intercept always occurs when x is equal to 0. So if we have a slope of 3/2, our rise is 3, our run is 2, and a y-intercept of -2 would occur at 0, -2. So to graph this, let's start at our y-intercept, or 0, -2. And that occurs right there. And then we're going to use our slope, or our rise over run. So we have 3 and then 2. So our rise is 3. We're going to go up 3. And then we're going to go over 2. And we'll find a point right there. We can do this again. Go up 3 because that's our rise, and over 2 because that's our run. We'll end up with another point right there. So we'll connect the dots, and that's the equation for a linear function with a slope of 3/2 and a y-intercept of -2. So let's try this one more time. Here we have a slope of -3, and think of that as -3 over 1, and a y-intercept of 4, which again, y-intercepts occur when x is equal to 0. So we would have a point at 0, 4. So let's go to 0, 4 on our graph, which is right here. And then our rise is -3, and our run is 1. So since our rise is negative, we're going to go down 3, and then over 1. And put another point. Then we can do this again, down 3, and over 1 is our next point. Then we'll connect the dots, and that is the graph of our linear function with a slope of -3 and a y-intercept of 4. Now you may have already seen the standard form for linear equations, which is right here. But what if we're given a slope and a y-intercept? If we are, there's an easier form for linear equations. It's called the Slope-Intercept Form, and it looks like this. Y is equal to mx plus b, where m is our slope and b is our y-intercept. Now it's easy to go from standard form to Slope-Intercept Form. You would just subtract ax from both sides. You'd end up with by is equal to -ax plus c, and then divide everything by b. We'd end up with y is equal to -a over b times x plus c over b. So now this is in slope-intercept form. Our slope would be -a over b, and our y-intercept would be c over b. So say we're given a slope of 5 and a y-intercept of -1. Could we write this in slope-intercept form? Well, our slope-intercept form looks like y is equal to mx plus b. Remember, our slope is equal to m and our y-intercept is equal to b. So we just plug these numbers in for m and b. So we would get y is equal to 5 times x plus a -1. So our slope-intercept form of our linear equation that has a slope of 5 and -1 would be y is equal to 5x minus 1. Now say we're given a slope and one point on the line. Could we write this linear equation in slope-intercept form? Well, again, our form is y is equal to mx plus b. And we have our slope, that's our m, but we don't know our y-intercept b. But we do have one point on the line. So what we'll do is we'll plug this x and y value in for x and y. So what we'll get is 1 goes in for y, 3/2 goes in for m, -2 will go in for x, and then we'll have a plus b that we're going to solve for. Now 3/2 times -2 is -3, which is equal to 1. And we have our b. So we'll add 3 to both sides. And we'll find out our b is 4. This means our y-intercept occurs at 0, 4. So let's write this in slope-intercept form. Again, it's y is equal to mx plus b. So let's plug in our slope of 3/2 for m and our intercept of 4 for b. And we'll end up with y is equal to 3/2 times x plus 4, which is our y-intercept. So our linear equation in slope-intercept form is y is equal to 3/2 x plus 4. Now say we're given a linear equation, can we use slope-intercept form to help us graph it? Well, first we have here a linear equation that's already in slope-intercept form, which is y is equal to mx plus b. Here, our 3/4 is going to be our m, or our slope, and then our -8 will be our y-intercept. So if -8 is our y-intercept, let's go to 0, -8 on our graph, which is way down here. And then our slope is 3/4, or our rise is equal to 3, and our run is equal to 4. So we'll go up 3, 1, 2, 3, and then over 4. And then we'll go up 3 again, 1, 2, 3, and then over 4, which is right there. And we'll connect our dots. And that's the graph for a linear equation of y is equal to 3/4 x minus 8. Let's try this again with the next example, except this one is not written in slope-intercept form, so we're going to have to put it in slope-intercept form. So here I'm going to subtract 4x from both sides. We'll end up with -8y is equal to -4x plus 16. I'm going to divide everything by -8 to get the y by itself. We're going to end up with y is equal to 1/2 x minus 2. Now here, this is in slope-intercept form, which means 1/2 is our slope, and -2 is our y-intercept. So we're going to go down to 0, -2, which is right there. And then our rise is 1, and our run is 2. So we're going to go up 1 and over 2, put a point right there. And then up 1 and over 2 again, put a point right there. Then we're going to connect our dots. And there is our graph for the linear equation y is equal to 1/2 x minus 2. So now let's see if we can apply slope-intercept form to a word problem. Jim signs up for a new online video game. He gets 500 points just for signing up, and then 50 more points every day he logs in. Write an equation in slope-intercept form that shows the relation between the amount of points Jim has and the amount of days he signs in. What is the slope and y-intercept of this equation? What do they mean? Then graph the equation. Now if Jim wanted to use these points to buy a t-shirt that costs 3,000 points, how many times would he have to sign in? Let's think about what's going on first. Before Jim ever signs in, he signs up. So on day 0, Jim has 500 points. If he signs in the next day, so day 1, he gets 50 more points. So he's going to have 550 points. Now if we graph this with points on the y-axis and days on the x, that would mean our day values are our x values and our point values are our y values. So really we have 2 points here, 0, 500 and 1, 550. Well, with these 2 points we can use this to solve for our slope. And our slope formula is m is equal to y2 minus y1 over x2 minus x1. So if we plug in for that, we'll get m is equal to 550 minus 500 over 1 minus 0. So our slope is 50. Now if our slope is 50, we need to find out our y-intercept. Now remember, our y-intercept always occurs when x is equal to 0. Well, when x is equal to 0, Jim has 500 points. So our y-intercept is right here. It's 0, 500, or our b is equal to 500. So the equation that shows the relation amount of points versus the amount of days he signs in is equal to y, which is equal to 50 times x, which is the amount of days he signs in, plus 500. So our slope is 50 and our y-intercept is 500. What do these mean? Well, our y-intercept is just the 500 points that Jim starts with. And then 50 is the amount of more points he gets per day. So let's graph this equation. We know our y-intercept is at 500, 0. So here's 0 and 500, which means our y-intercept is right there. Then he's going to go up 50 points per day. Well, if he goes 10 days, say, we'll plug 10 in for x. So we'll get y is equal to 50 times 10 plus 500. And we're going to get a y of 1,000. So in 10 days, he's going to have 1,000 points. So our next point would be right there. And we could connect our dots. And that is the graph of our linear equation, y is equal to 50x plus 500. Now, if Jim wants to buy a t-shirt that costs 3,000 points, how many times would he have to sign in? Well, we can use our equation, or we can go to our graph. Let's use our equation. We have y is equal to 50x plus 500, and y is our amount of points. So let's plug in 3,000, because that's what we're curious. 300 is equal to 50x plus 500. And now we have to solve for x. So we subtract 500 from both sides, and we're going to get 2,500 is equal to 50x. So let's divide by 50. We're going to get x is equal to 50, or 50 days. So Jim would have to sign in for 50 days to get 3,000 points. Let's check this on the graph. If we go up from 50 and hit our function, and then go back to the y-axis, he does indeed need 50 days to get 3,000 points.